Hello and welcome to Module 2. This is ClickHouse Architecture. And in this module, we're going to take a deep dive right away into how merge tree table engines store their data. There's just some very important terms that you need to understand if you're going to get anywhere in ClickHouse. You need to know how primary keys work. You need to know what a part is. You need to know what a granule is. And you need to know how the primary index works. And so those fundamental aspects that really make up the architecture of ClickHouse are what we're going to discuss in great detail in Chapter 2. And for what it's worth, if you're new to the learning path here, this is Module 2 of 12 modules that we're calling ClickHouse Developer. And the goal being, if you complete all 12 modules, you'll be nicely prepared for the ClickHouse Certified Developer exam. You'll also learn a wealth of information about ClickHouse. All right, so let's get started. So let's take a look at how ClickHouse architecture works and how really what I want to talk about is how the data gets stored in ClickHouse with merge tree table engines. You know, there's lots of table engines in ClickHouse depending on where the data sits. You know, if your data is in S3, you can use an S3 table engine. If your data is in MySQL, you can use the MySQL table engine. But when it's time to put the data into ClickHouse, we use the merge tree table engine. That's the one that you're going to use to take advantage of all of the great speed and features and everything that ClickHouse has to offer. It all evolves around one of the several merge tree table engines. And there's more than one. It's actually a family of table engines. If you go to the documentation, under the SQL reference, we have all the table engines listed. And you can see that the merge tree family has its own section in the docs. There's replacing merge tree, there's summing merge tree, aggregating merge tree, and so on. And we'll talk about these in later courses as we work through the training here. I have a very simple table here. It's called my_table. I have 3 columns. I very boringly named them column 1, column 2, and column 3. And I picked simple types. The first column is just going to be a character. The second column is going to be a 32-bit unsigned integer. And the third column is going to be a string. Notice you put engine equals merge tree. That's this particular table. And I decided to order by column 1 and column 2. Now, the order by, the sort order, is kind of a big deal in ClickHouse. In a merge tree table, in this example, the sort order is the primary key. And the primary key in ClickHouse is not necessarily unique. So this is one of the main goals I want you to take away from this conversation. I want you to understand what a primary key is in a merge tree table. It is how the data gets sorted on disk. And there's a very fundamental concept that comes out of that called a granule that we'll talk about in just a little bit. But first I want to talk about, I want to kind of go through what it looks like as you insert data in and how it gets stored. And then we'll see how the primary key plays this important and kind of interesting role. Now you can have a primary key that's unique to every row, but that doesn't mean that every row is going to be unique. That's just not how ClickHouse works. So if you're coming from another database where that's always, probably been the case in a transactional database, in ClickHouse, you can have millions of rows with the same primary key. I'll show you why. I'll show you why that's interesting and why that's like I said, a sort of fundamental concept of ClickHouse. By the way, if I go back a slide, I had order by on this table definition. Here I change it to primary key. It doesn't matter. They're the same thing. And you can have a different sort order than the primary key. We'll see that in the next module. But, for a lot of situations, it's usually the exact same thing. So let's take a look at how merge tree tables store their data. I have a very simple example where I insert, looks like 8 rows into my table. Now, even in this sort of hello world type example, I'm inserting 8 rows. I'm not going to insert 1 row at a time. We try to not do that in ClickHouse. You try to insert as many rows as you can. In fact, in a perfect example, you would insert tens of thousands of rows or maybe even 1 million rows if it's possible, all in one insert. Why? Why do we try to insert as many rows as possible? Because every time an insert gets performed in ClickHouse, behind the scenes, those rows in that insert get put into their own folder. And that folder has a special name. We call it a part. And so in this example, I only have 8 rows. Those 8 rows are going to be stored. We split them apart into the column files and they'll sit inside their own folder. Just these rows. And so, by the way, if you do insert 1 row at a time or you just don't have the ability to insert 10,000 rows at a time, make sure you understand how async insert works. That's a feature. All you have to do is turn it on and we'll buffer some of those inserts for you. And there's also a table engine called buffer table engine, but that's a little bit more work. Async insert, you just have to turn on. So please make sure you're aware of that concept. We'll talk a little bit more about that when we sort of get into the best practices towards the end of this training. But for now, just keep that in mind. Please don't insert one row at a time. Why? You'll get too many folders. Now that does seem odd that you're sort of only going to have these 8 rows in a folder. And you can see I drew this picture here on the slide that kind of looks like a folder. And it has more files in it than what I showed on the slide. But you absolutely will see a file called column1.bin, column2.bin, column3.bin. Now remember, those were my boring column names. If your column names are actual interesting names, those would actually be the names of the files. There will be a file in there called primary.idx. And I'll talk about that after I get done talking about parts. We'll come back to that. Notice here, I only have one entry in this primary index. More importantly, notice that column 1 and column 2, which were the primary key, is how the data is sorted. For example, all the A1s come first. Then it looks like there's one A2, and then a couple of B1s, and then a couple of B2s. So this data is absolutely sorted by the first 2 columns. All right, so keep that in mind. I specifically drew this picture. I know it only has 8 rows. I wanted it to fit on the slide so you can see it nicely. In a sort of realistic environment, you're going to have these inserts. And as you look at this picture where we travel left to right, you can see the little time arrow at the bottom. I'm picturing maybe let's say every second, you're inserting 1 million rows, which in ClickHouse is perfectly feasible, perfectly realistic. Well, then those million rows, the first million rows are going to go into their folder, and then the second million rows go into a second folder, and so on. Well, look, after a minute, you'd have 60 folders. After an hour, you'd have 3,600 folders. That's way too many folders, let alone all the files that go inside there. That's too many files. Well, what ClickHouse does behind the scenes so that you don't get too many folders, you don't get too many parts, is ClickHouse merges those parts in the background. It's one of the reasons why it's called a merge tree table. So over time, and that's a very vague statement that I have on the slide, over time means really whenever ClickHouse feels like it, whenever ClickHouse thinks it's time to merge parts, it'll merge those part folders in the background. And so like 2 parts might merge into one folder. You could have 100 parts merge into one folder. It just depends on, how many parts you have and how the merging algorithm is, whatever it's thinking at the time for making smaller parts into bigger parts. But it keeps going. It goes on and on. So what sort of keeps you from getting too many parts is that after merging, the unused parts get deleted. So if they're no longer being used in a query, ClickHouse will throw those folders away. So I'm still inserting 1 million rows per second. So I'm still getting new parts, but ClickHouse in the background is merging those parts into one part. Or it's not one part, but it's taking a bunch of folders and merging them into one part. And so you get these merged parts. Well, eventually they might merge into a folder. Now, this picture makes it look like all your parts merge into one folder. That's not the case at all. In fact, you can see that setting there that's on the slide. After about 150 gigabytes, that particular part won't merge anymore after it exceeds that amount of disk space. Now, 150 gigabyte is a lot of rows. Remember, this is compressed data. You could have billions of rows in there inside one part. That's a great place to be, by the way, to have nice big parts like that. ClickHouse likes that. Like that's a good, a good scenario to have a lot of rows inside a part. So you have all this merging of parts happening in the background. You're still putting rows in. That's how the parts work. And I want you to understand that. Now I'm going to sort of change subjects here. I want to talk about that primary index file, which is built off the primary key. So when you create a table, a merge tree table in ClickHouse, you get one free index. It builds one index for you. And we call it the primary index. It's built off the primary key. And it's very simple, but maybe a little bit confusing how it works because it almost is kind of simple. What ClickHouse does is it looks at your data logically, the way it's sorted, as something called a granule. And a granule is simple. It's just 8,192 rows. And the primary index is the value of the primary key of the first row of every granule. So for example, in our, I'm assuming that I have maybe millions of rows now inside my simple table that I have. So A1 looks like it's the first primary key. Well, then that's the value, that's the first value in the primary index. And then row 8,193 is the first row of the second granule. And it looks like in my picture, that's also A1. And then it just keeps going on and on. So row 16,385, that's the first row of the third granule. It looks like that's A2 in my example. Row 24,577, that's the first row of the fourth granule, and so on. So for every, you can have millions and millions of rows, and your primary index will be very sparse. It'll only have hundreds or thousands of entries. It would take billions and billions of rows. Even then, you'll only have like tens of thousands of entries in the primary index. So it's quite small. It's small enough to fit in memory. In fact, it lives in memory. Now, there is a file called primary.idx, but that's kind of like a backup file. It never reads that file. The primary index is always sitting in memory. And here's what it does. Here's the benefit of that. Let's say I write a query where column 1 is equal to A. I'm filtering by column 1 equals A and column 2 equals 2, which just happens to be the third entry in my index here. Well, if you think about it, the fourth granule and every one after that can be skipped. It isn't possible that there's a row in the fourth granule where column 1 is A and column 2 is 2, not just the fourth granule, but any of the maybe of thousands of granules. I can skip all of those. I only have to read, granule 3 for sure. I can completely skip granule 1. It's not possible for an A2 entry to be in there. And it is possible that granule 2 could have some rows with A, 2 at the end of the second granule. So ClickHouse will take these 2 granules and process them, even if you have, tens of thousands of granules. And that's the beauty of the primary index. That's the beauty of the primary key. Instead of reading a billion rows, I can read 2 granules worth of rows, 16,384 rows. And it even kind of is more than that. So the granule turns out to be the smallest number of rows that ClickHouse will even bother working with. It only works in the, if you select one row, ClickHouse is going to grab 8,192 at a minimum to find your one row. Like, it's the smallest amount of data that ClickHouse works with. If you did have multiple columns, like here I drew on the slide, I have columns 3, 4, and 5. I don't even have a 4 and 5 in my table. But if I did, ClickHouse figures out which granules from each column to grab, and it puts them together, and it calls them a stripe of granules. Okay, that's not a huge, concern. I just want you to kind of understand how it works behind the scenes. I don't want you to get lost on that. But what I do want you to understand is that stripe of granule, whether it's one granule or maybe it's 3 or 4 columns that you've selected, it's this 8,192 rows together that get sent to a thread for processing. And the threads are already sitting there. ClickHouse keeps a nice, pool of threads already running, waiting to go. You've got 128 cores on your massive machine. You send 50 stripes of granules through a select query. That's nothing for ClickHouse. ClickHouse, those 50 stripes of granules can easily be handed off to 50 threads just sitting there waiting to go. Assuming your CPUs aren't busy, they could all run at the same time. Well, that's a lot of rows of data, being processed concurrently at the same time. And if one of those stripes of granules is taking too long, ClickHouse will simply send that same set of rows to another thread. And so ClickHouse is constantly doing everything it can to query these rows as fast as possible. And it's quite fascinating how it works. So that concept of a granule. Now, this isn't how your data is stored. If I go back a couple slides here, your data isn't stored by granules. It's just sorted, and ClickHouse logically looks at your data as if it were in these chunks of granules. And ClickHouse knows where the start and end of each granule is, so it can very quickly grab the 8,192 rows. Okay, so why do we need to know the internals? Well, it's really important to understand this terminology. You're going to see the word granule all the time. You'll see it in your table definitions. Even if you don't add it to your table definitions, the default value of a granule is 8,192, and you'll actually see it in your create statements. And so it's very important to understand what that is. And you'll see the word granule all the time when you're reading the documentation. I'll use the word granule a lot as we sort of look at queries and how they work. The primary key is the most important decision you'll make when defining a merge tree table. It's that simple. The primary key is how the data gets sorted. The primary key should be the values, should be the columns that you filter on the most in your where clauses of your queries. And that's essential. And I'll say that many more times as we go through this. So whatever your sort order is, that's your primary key. This primary index is built for you behind the scenes. It's that sparse index. You can have more than one index on a table. We'll talk about that way later on towards the end of this training. And then, of course, I think it's just critical to understand how parts work. You're not going to get very far in ClickHouse if you don't understand that every insert creates a part folder, because you can get too many parts. That's one way to get too many parts, is to not insert enough data. There's other ways to get too many parts. You might be partitioning by too much or something. And I won't even talk about partitioning until the next module. So like I said, I really want you to understand those terms. I love this question. It says, what's a good primary key for this table? I have this table that looks like property data, very similar to that UK price paid table that we saw in the previous module. And the question is, what's a good primary key? Well, that's really not the question to ask. It looks like there's a price of the property, the date it was sold, and some address, postcode, town, county type information. Look, the question you need to ask yourself is, what do my queries look like? What am I filtering by the most in my queries? For example, if every single query you write filters by date, then you better put date somewhere early on in the primary key, if not the first column. And keep going with that logic. If you filter, if most of your queries filter by town, then town would be a great candidate to be the first column in your primary key. And then put date on the end or something. You want the lower cardinality values earlier in the primary key, because remember how granules work. If you have a lower cardinality column and you put that right away as the first column in the primary key, you could skip all kinds of rows. And I have an example. Here, let me show you something. Remember that UK price paid table? And I'll just run this in case you didn't see if you haven't seen that table yet. It has, things like the price of the property, and then it's got other details, but you can see things like town and so on. And if you look closely, I want to show you this. I'm going to do a show create table, UK price paid. And if I click on that, you will see my primary key. You can see all my data types and my column names. The order by, which is the primary key, was postcode 1, postcode 2, address 1, and address 2. Notice I didn't specify the granularity, the index underscore granularity, to be anything, but you can see it's the default setting there. I called it merge tree, and in the cloud we convert that to shared merge tree. That's a conversation for a later module, but just something to be aware of, that it is a merge tree table. And it looks like postcode 1 and postcode 2 are gonna be the columns that really benefit from this. Okay, so let me show you something. Let me run a query. Let me select the average price from UK price paid. I'm going to filter by column 1. Not column, I mean it was column 1 and column 2 but it's the first two columns. So postcode 1, I'll just pick a value. I'll do AL1 and postcode 2 equals 1AJ. I have no idea where that is in the United Kingdom, but it is two valid values for postcode 1 and postcode 2. And notice that query only had to read 8,192 rows. That's an interesting number. Well, that's exactly how many granules I have. Look, if I run the query again and I only put in postcode 1, well, that had to read 32,768. If I do some quick math here on my Mac, that is 4. Well, that's exactly 4 granules. That's how many had to be processed there. Here, let me run the same query again, except this time, let me filter by town equals, I'll just pick the most obvious town I can think of in the United Kingdom. Town equals London. It isn't the value that I'm interested in. It's the fact that it had to read 28,782,630 rows. Wait a minute. If I do a select count from UK price paid, that's exactly how many rows there are. So to run this query, the primary key didn't help me at all. Well, town is not a part of the primary key. It's not one of the columns in the primary key. So the primary key didn't benefit me at all. Now we'll talk about this later as we go on. There are other ways you can create other indexes. You can store the data twice. You can create a materialized view, something called a projection. We'll talk about ways around that. So just keep that in mind. But for now, we're just going to have to focus on what we know. And that's you pick a good primary key. All right. So in the lab, you're going to do something very similar to what I just did. You're going to write some queries. You're going to figure out how a good primary key can skip a lot of granules. That's in the first lab. And then in the second lab, you're going to see how primary keys can affect how compressed your disk space is by simply picking a clever ordering of your columns. And sometimes you can't always do that because your queries kind of force your primary key. But if you do have an option, it's a really interesting lab. So I want you to check those out. Like I always say, if you ever have any questions, feel free to find us on the community Slack channel. And there's a channel in there for the ClickHouse Academy. So ask your questions there and off you go. Good luck.